Hi guys, welcome back to Chem Talks. Mr. J here once again. Today we are going to continue on with our discussion of the mole and move it into percent composition, looking at how much each element comprises 1 mole of a compound. So let's go ahead and get started. Percent composition simply refers to the percent of each element present in a compound. So we're going to be talking about compounds and how each element contribute to those. Okay, what we're looking at is percent by mass or by weight of each element in a compound. So for example, if we take magnesium phosphate, we could ask a question like, what's the percent of the mass is due to magnesium? It's pretty easy to do, so let's go ahead and start looking at this. Alright guys, the first thing we need to do to calculate percent composition is to figure out the formula weight or formula mass of the molecule we're looking at, the total weight of that molecule. Then once we do that, we can take the weight of the element, of the given element, and divide it by the molar mass of the molecule, and then we multiply it by 100 to get it into a percentage. So if we put it into an equation, it looks like this. We take the grams of the element, divide it by the grams of the compound, times it by 100, which gives us the percent of the element. And yes, you do need to memorize this, so make sure you have it written down. Okay, let's go back to that magnesium phosphate. We said what mass is due to the magnesium? What percent of the mass is due to magnesium? So first time we have to figure out the formula weight or molar mass of it. So we know magnesium is 24.31. There's 3 moles of that. We know phosphate is 30.97, but there's 2 of it. Where's 2 come from? Well, the 2 here gets distributed not only to the P, but also to the O, so that gives us 8 oxygens at 15.99. Okay, so we add it up and get a total mass of 262.79 grams. So 1 mole of magnesium phosphate will weigh 262.79. And I like to write it this way because now when we do the next step, we take the mass of magnesium divided by the total mass. We have our information right up here. So we take 72.93 divided by 262.79 times by 100, and we get a percent of 27.75% magnesium. That means 27.75% of that compound is made up of magnesium. Okay guys, I'm going to give you 3 practice problems. I'll show you all 3 of them, then I want you to pause it, do the practice problems on your own, then come back and we'll go over the answer. Do these practice problems, the only way to learn. Don't just cheat and watch the video. I'm talking to you, so go ahead and do these. First one, I want you to figure out the percent composition of carbon in this element. Second one, what's the percent of oxygen and calcium hydroxide? And then third, if we have ammonium nitrate, what's the percent composition of hydrogen? So pause the video now, do these practice problems, and then hit play and we'll watch and find out the answers. Okay, so the first one we have to figure out the formula weight of 1 mole. So we found out that 1 mole of it weighs 222.24 grams, and 2 moles of carbon is 24.02, so 24.02 divided by 22.24 times 100 is 10.81%, so it's 10.81%. Problem number 2, the correct formula, first of all, was CaOH2. Don't forget the parentheses on this. Remember, hydroxide is often forgot, so the 2 will be for oxygen and hydrogen. So we take 32.00, which is for oxygen, because there's 2 oxygens here, right? Divided by the total formula weight of 74.10 times by 100, and you get 43.18%. Remember, 2 oxygens from here, so that's where we get the 32. Okay, not just 16, but we have 2 oxygens, so we have to count for both. Now the third one, ammonium nitrate, the correct formula, NH4NO2, nitrate, excuse me. Okay. The total molar mass is 64.06 grams. Okay, take the weight of hydrogen. There's 4 of them, so 4.04 times 100, or 4.04 divided by 64.06 times 100 gives us 6.31% hydrogen. Not too hard, guys. Pretty easy. Okay, how about this one? Find the percent composition of a compound that contains 17.6 grams iron and 10.3 grams sulfur. So what we want to this is what's the percent composition of iron and sulfur? Well, we don't know the chemical formula, but we do know how much the total compound weighs, right? Well, it's 17.6 grams of copper and 10.3 grams of sulfur. Excuse me. Okay, let's try a different practice problem. In this one, we're going to find the percent composition of a compound that contains 17.6 grams iron and 10.3 grams sulfur. We don't know the formula of it, so we can't figure out the formula weight, but we do know the weight, or the total weight of this compound. It's the combination of these two. So we take 17.6 grams plus 10.3 grams, and we find a total mass of 27.9 grams. Now that we know this, we can divide each of the elements by the total to figure out the percentage. So 17.6 divided by 27.9 times 100 means it's 63.08% iron. Okay, to find sulfur, two ways. We can take 10.3 divided by 27.9 times 100, and it gives us 36.92. The other thing we could have done, since we know it's only two compounds, once we got the iron, we could have taken 100 minus 63.08, and that would have given us 36.92. Either way will work. Now, what we need to know is that the percent composition in a compound is constant, okay, due to the fact that the formula doesn't change at all. Okay, if we go back to that last one, whether we had 30 grams of that substance or 100 grams or 300 grams, it's always going to be the same percent composition. So once you calculate a percent composition, you can apply that to any amount of the substance. So let's look at potassium phosphate. Okay, what's the formula for this? Stop and write it down real quick. Did you get K3PO4? I hope so. Okay, what's the mass of 1 mole? How much is 1 mole? Wait, write this down and come back and check. 212.27 grams. Okay, what's the percent now of potassium? Well, we're going to take 3 potassiums divided by 212.27 grams times 100, and what we get is 55.26 percentage of it is potassium. It doesn't matter if I have 1 gram, 1,000 grams, 10,000 grams, a billion grams. Okay, it's always going to be 55.26% potassium for potassium phosphate. So if I'm given 1,208 grams of potassium phosphate, how many grams of potassium will I have? Well, I know the percentage. Now all I have to do is take the mass times the percentage in decimal form to get the grams. So I take 1,208 times our percentage. It was 55.26. To get in decimal, we move the decimal place 2 points, so it's times 0.5526, and we get a total of 667.54 grams of potassium in this 1,208 grams. Pretty simple there, guys. Okay, remember, we take our percentage and make it into a decimal form by moving it 2 decimal places. Or what can you do? Divide your percent by 100. It's the same thing, just a different way of saying it. Alright, I want to talk about a special type of compound, and these are what we call hydrated compounds. If you're well hydrated, that means you're full of water. Okay, you're not dehydrated. You have lots of water in you. Well, hydrated compounds are the same thing. They have water in them. They occur when certain ionic compounds, they crystallize. And when they form this crystal structure, they actually trap water molecules inside them. Okay, it's kind of like if you blew up a balloon and put a marble inside it. The marble will be like your water trapped inside. We call these substances that have water trapped inside hydrated compounds. And it's important to know that a substance is hydrated because when you calculate the formula weight, you must include the water. Not only in its mass, but you also must show it in the formula and in its name. So here's an example: sodium carbonate decahydrate. Okay, that little dot here, right here, indicates that it contains water. It doesn't mean times 10 water, it means contains 10 waters inside of it. So look at this one again. Okay, the name is sodium carbonate decahydrate. We use prefixes in front of the word hydrate to tell us how many Let's take a look at this one again. Sodium carbonate, I said decahydrate. Okay, we use prefixes in front of the word hydrate to indicate how many waters are in there. What this dot means is that there are 10 moles or 10 molecules of water trapped inside here. If we're talking a single molecule, it's going to be 10 molecules of water in 1 molecule of this. If we're talking moles, it's 10 moles of water in 1 mole of sodium carbonate. Okay, so figure out the formula weight. First thing we need to do is figure out the sodium carbonate. We got two NAs, 1 carbon, 3 oxygens. Now we must include the water. Well, I have 20 hydrogens, 10 times 2 is 20, and I have 10 oxygens. Okay, so I add this all up, I find the total formula weight is 286.19. We have the top part here, which is the sodium carbonate, and then we have the water. I kept the 2 waters separate here. It makes it a little bit easier for some work that we're going to do later. So I suggest doing your water separately. So what's the percent sodium in that previous compound? Well, what we have to do is we take the amount of sodium, which is 45.98, divided by the total formula weight times 100. So it's 16.07%, same as we have been doing earlier. This is why writing it out like I did makes it a little bit easier, okay? Especially when I ask you what's the percent water. So rather than having to go back and re-separate our oxygens, we can just do it this way. 180.20 divided by 286.19. Where did I get this 180.20? The hydrogen plus that bottom oxygen. And so 62.97% of this compound is water, so most of it is water weight. Okay, just like you get dehydrated when you work, when you get heat up, we can do the same thing with hydrated. We can drive off the water by heating. If we heat it slowly, the water is going to evaporate. When this water is driven off, we call it an anhydrous compound, which means without water. Okay, anhydrous without water. So if we determine the mass of something, weigh the mass of something before we heat it and then after it, the difference is the amount of water. So we can use this heating to determine the amount of water that a crystal solution will contain. Okay, so let's take barium chloride. So, for example, what would the formula of the hydrated compound, that means with water, be if it had a formula weight of 244.27 grams? Okay, so what we need to do now is first find out the weight of barium chloride. We know how to do that. We come up with 208.23. So this is how much it would weigh without the water. But we know that with the water it weighs 244.27 grams. So the difference between this number and this number must be the water. So we do a little subtraction between the two and we come up with 36.04 grams. That's how much the water weighs. Well, 1 molecule of water, we know, weighs 18.02 grams. So if we take 36.04 divided by 18.02, that means we come up with 2. So for every molecule of barium chloride hydrate, we have 2 molecules of water. For every mole of barium chloride, we have 2 moles of water. Now, how do we name this? Okay, how would we write the formula? BaCl2 contains, what that means, 2H2O. What would the name for this be? Barium chloride barium chloride dihydrate. So in order to figure out the percent composition of water, we do like we did before. We figured out percent composition of barium, percent composition of chloride, and then we take the water. Okay, took 18.02 divided by 224.27, which is our total mass, times 100, and then I times it by 2 to get, why 2? Because we had 2 waters. You could have also made this number 36.04 divided by 24 times 100, and you should come up with the same number. Okay, so like I said, we multiply here because we had 2 waters in it. Okay guys, so this one we learned how to figure out the percent composition. We take the mass of a single element in there, if it's however many we had, divided by the total mass of it, times by 100, gives a percent. Then we learned about hydrated compounds. Hydrated compounds, remember, are compounds, ionic compounds that contain water inside them. That dot between the first formula and the water means it contains water. Alright guys, we are going to do a lab on this in class, which is why we went over it. Make sure you understand what we're doing and how to write out the names and how to figure out percent composition, because we will start this lab probably next class. So until then guys, if you have questions, come see me. Otherwise, take care and we'll talk to you soon.